guys, welcome back to my channel. My name is Kenroy Carty. Please remember to like and subscribe. Now today we'll be looking at tangents and normals to a circle. We're just going to start with a simple circle. Now the first thing I want to put inside of this circle is the center of the circle. And that center I'm going to call it AB. Now we can have a radius here and we're going to draw a tangent to the circle. At that point, now the tangent will touch the circle at only a single point. At the point where the tangent touches the circle, we're going to call that point A. We're going to call it x1, y1. In the center of the circle, we can probably call that point C. Now, there's a relationship between the radius and the tangent of a circle at a given point. They form a 90-degree angle. So incidentally, the radius is also referred to as the normal of the circle. So I'm just going to use a capital N here for normal and a capital T here for tangent. The tangent and the normal are both straight line, so both of them will have straight line equations. However, if I want to find the gradient, and that will be my first problem, to find the gradient of a tangent is going to be a big problem as we only have a single point that the tangent passes through, which means that I would have to start by finding the gradient of a normal and use a connection between the normal and the tangent to deduce the gradient of a tangent. So let us start by finding the gradient of the we're going to call the gradient of the normal mn, m with a subscript n. Now, of course, we know the formula for finding the gradient already, as we know it is y2 minus y1 over x2 minus x1. So in this case, using these two set of points, I'm going to have y1 minus b over x1 minus a. And once you have the gradient, you can use any point that the normal passes through to find the equation. So we're not going to look at the equation yet. Let us talk about the gradient of the tangent. Since the normal and the tangent are perpendicular, we know that this relationship will exist. If the gradient of a normal is mn, when I multiply that by the gradient of a tangent, which I'm going to call mt, I should get -1, which means the gradient of the normal, the gradient of the tangent, which is mt, is the negative reciprocal of the gradient of the normal. So we can say -1 over mn, which in this case, by referring to the equation that we have up here, would be equal to negative x1 minus a over y1 minus b. And that is how we get the gradient of a tangent. So technically, we have to find the gradient of the normal first before we can find the gradient of the tangent. We should also mention the fact that a calculus technique could have been applied here, but we're going to leave that for a later lesson. So we can make the connection to show that if we use calculus or we do it this way, then the answer will actually be the same. Please join me in my next video where I'll be showing you some examples.